Peace and love. I'm out. What's up? How you doing, man? Same as a lot of people like to call me Certified Material. You can call me Now River Donis, Now River Soldier. Don't play with us, man. Let's get started. So now let's say, so this is very important. I want to show you the breakdown of the whole quadratic. How would you know something is quadratic? In equation, I've got standard form. Okay, so standard form of quadratic. If you have a x squared plus b x plus c, this is quadratic. If something in this form, for example, if somebody gives you, let's say 4x squared minus 6x plus 7, this is quadratic. Why? Because one of x has a degree of 2. So since this has a degree of 2, then it's quadratic. So it should not be 1 degree or 3 degree. If it has the maximum degree of all of these x is 2. See, this is like power 1, but this power 2. So it means, oh, this is quadratic. What that means a, you see this number here, a equals 4. What is b? Look, so this is what you do, look. So my b equal to -6, b equal to -6. What about c? You do this. When you take with this side, my c equal to 7. So this is quadratic because the highest degree of x is 2. For example, somebody give you 4 minus 4x minus let's say 6x squared plus 1. Is this quadratic? Oh yes, because if I look all this x, the highest degree of x is power 2. The highest, if it's power 2, quadratic. Yes, this is quadratic. Why? So first and foremost, I have to rearrange in this form. Which form? It has to be in this form of, this is standard equation of quadratic, ax squared plus bx plus c. So this one means I have to rearrange. If I have to rearrange, it means this is going to start. When you take any number, you must start with the sign. You must take with the sign. And the sign of any number is on the left. Means this is going to start here. It's going to be -6x squared. And then this is going to follow. So if there's no sign, means the sign is positive. Sign on the left, sign on the left. So this is going to be plus 4x, and then this is gonna be the last one. See, this is standard form of quadratic. So for that case now, what is our a? Our a, you must do them, okay? A equal to -6. What is our b? Oh, so our b equal to +4. And what is our c? Our c equal to 1. So now you need to know that. So I'm going to show you a very simple formula. For the most cases, you can memorize this, or sometimes they give you a formula sheet. So no stress. Now, let's say here, we have to find the maximum value, minimum value, stationary points, quadratic, graph. We have to draw turning points, axis of symmetry, intercepts, point of intersection, vertex, if they are. Okay? Now let's go. If we have. So now let's go and get all those stuff if they have. Excuse me. Let's start with the first equation. So first, before we get started, excuse me. Before we get started solving this, if somebody give you a question, let's say this is ax, we know this is standard equation of a quadratic. So somebody give, let's say, negative, positive, let's say 3x squared minus 5x plus 4. If this value of a is greater than 0, what is a? This is a. If the a is greater than 0, because 3 is greater than 0, then when we draw your graph, because the graph of quadratic, if I have already identified this is my quadratic, either the graph could be either concave upward. So the graph of quadratic, we call it parabolic. 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 1L. Parabolic. Parabolic. You know what I'm saying? Parabola. Not parabolic. I should say parabola. 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 You know what I'm saying? Is parabola. So means if it's quadratic, means this is parabolic function. Excuse me, my problem. Parabolic function. Parabolic function. Okay, now, so just by looking at a graph, if this is less than 0, the graph is going to concave downward. So for now, I don't know where it's going to cut, but this is a rough case. So this is greater than 0. If it's greater than 0, like here, the graph, excuse me, I was meant to say the graph is going to concave upward. So it's going to concave upward. Before you even start to draw, it's going to concave upward. And after rearranging in a standard form, I have to look at this. These are turning points. So since it's going to concave upward, excuse me, and we know this is a value of y, means it's going to cut at 4. So this positive tells it's going to concave upward, and where it's going to turn at 4, means it's going to go like that. For example, now we don't want to do all of them just to see, to tell me like where it's going to concave. If I look at the first one, it's going to concave upward. Why? Because a is greater than 0. So I'm going to say, oh, since a is greater than 0, means this graph is going to concave upward. But at which point? At 3 here. You know what I'm saying? Now, for example, what about this one? This is going to concave downward. You know what I'm saying? It's going to concave what? Downward. So this is going to be like A. Whew, shows me, sorry. A is less than 0. Since it's less than 0 means the graph is going to concave downward because less than 0 means this is A. You can see negative 3x squared plus B. Do you have a B here? No. So something, okay, let me write. This is AX squared. Oh my god, my pen I finished. Okay, AX squared. AX squared plus BX plus C. Oh, my pen I finished. Plus C. Okay, let me get out of pen quick. Sorry guys. Plus B plus C. So, do you have a B here? B is something with 1x. No, we don't have. So, it's like a 0x. And C is 2, 4, 3. Oh, you know what I'm saying? But this is what we want for now. So, it's going to concave downward because this is negative. And where it's going to turn? It's going to turn 2, 4, 3. Means it's positive. This is 2, 4, 3. This is C. C is meaning y-intercept. Where it's going to intercept meaning where it's going to cut. So, this is a rough sketch here. It's not right sketch. I'll show you how to do the accurate sketch. You know what I'm saying? So now let's start solving this question quickly. Which question? It doesn't matter. Whichever question I can take. Okay, let me just take. Let's leave this question because I identify something with this question here. Okay, I'm not supposed. Okay, so what I'm going to do, I'm not going to use this question for some reason because it's something that I realized I have not shown you yet. Most of this question here, I'm supposed to take the question with the x-intercept, y-intercept, but for this, I'll show you in another topic. It's called root of quadratic. For example, the face. For now, you don't understand what I'm saying, but let's stick to that. Okay, cool. So now, for example, let me take. Let me not take none of this. Let me give another question, okay? And then this is going to be for another topic, okay? Please, I'm sorry about that. I'll take another question. Cool. This question here is the root of quadratic. So let's keep this. I'll give another question. Just a second. We back. Okay. For some reason, identify these questions supposed to be for the root of quadratic question. So this is not what I was looking for. Okay. Okay. So I'll take one question to another. Just a second, guys. I appreciate your patience. Okay, so somebody, for example, give you y equal to 4x squared, and then minus 8x plus 3. So we have to find all of the stuff there on top. Okay, all the stuff on top. So now we're going to say, now first and foremost, if I had to write inside of the equation, this is going to be a x squared plus bx plus c. So I know my a equal to positive 4 because if I do this, see, a is positive 4. So in other words, the value of a is greater than 0. So before even I get started, I know this graph is going to concave upward because this is 0, it's greater than 0. So since it's greater than 0, then I know my c is positive 3. This c tells me is y-intercept, where the graph is going to cut at y. Now let's draw, okay? Now before we do that, there's something called intercept. So I know roughly, before we get down to it, this graph is going to concave upward, but always going to cut at y equal to 3. C means y equal to 3, and then it's going to go up. Why is going to go up? Because the value of a is greater than 0. So it's like roughly something like this. But now I'm going to show you now how to get turning points, because look, if I have a graph like this, let's say roughly, there's no guarantee this graph is going to come and touch it, because it might come like this, or it might come like this. You know what I'm saying? Or it might be like this. So now if you look careful at the parabolic function, we got like 3-4 things we need to find. What are those things? For example, we need to get the turning point. So, okay, so this is called turning point here. This is a turning point where the graph turns, or sometimes we call it stationary points. Stationary point. How do we call the stationary point? Look, if I have a ball, or let's say orange, this is where it can stand. Here, no, it's not going to fall, it's going to fall, it's going to fall, it's going to come and stay there. That's what sometimes we call stationary points. So tiny point, stationary point, is the same game. Okay? So tiny point, stationary point, same thing. Let me get another black pen quick. That one is finished. Shows me. So tiny point, stationary point is the same thing. Sorry guys, just a minute. Sorry. So tiny point and stationary point are the same thing because that's what the graph turn. So if you look careful, oh, excuse me, sorry. Come on, man. It doesn't want to open. Sorry, my apologies. Okay, cool. I got it. So tiny point, stationary point. Now, if you look careful, there's something called x-intercept. X-intercept is the graph where it cuts at x-axis. This x-axis, this y-axis. So we have a 2x intercept for parabolic. Oh, so we need to find the tiny points. We need to find x-intercept, and then apart from there also, this graph remember is going to come and cut at y. So we have like 4 things. Y-intercept, where it's going to cut at y-axis. X-intercept, there are 2, and tiny points. And sometimes this is called vertex. See here, what turn is vertex. You know what I'm saying? So roughly, quick, let's go back again, just a minute, and then we go to the question quick. So now we need to find, if I have a graph like this, let's say concave downward. So what do I need? X-intercept, and then tiny point, or sometimes called vertex or stationary points, and then we need that. Okay, so these are very, very important. X-intercept, and these also x-intercept. Intercept. This is stationary point, SP, but it says stationary points, or sometimes we can call tiny point. Okay, so I'll show you how to get all of them. Or sometimes we can call it vertex. Vertex, okay, this is vertex sometimes. So vertex is like at the corner of something, you know what I'm saying? So that's a vertex. Okay, now let's find them. So if you find those 4 things, and then you can draw your graph. Now let's start with the x-intercept. So this is a very simple formula, okay? Or we can use to get all this stuff. Okay, cool. Now let's take that. So you have a 4x squared minus 8x plus 3. So what is x-intercept? When x-intercept, y equals to 0. So oh, when x-intercept equals to 0. So now, since this is quadratic, there's a very small formula that you're going to have to use. Either they give to you, or you can go to formula sheet. You know what I'm saying? They give to you, or you go and get to the formula sheet. So you saw the pen. Sound is cool. I remember in my my time when I was doing this stuff. Now we're not giving, you know what I'm saying? You have to memorize that time. So I think it's the new generation, they always give to you stuff. You know? Now, so this is a formula that you use. You say, x, to get this x value, equal to negative b plus or minus square root of b squared minus 4ac. Very simple formula to use. 2a. Okay, so I know my a, I know my b, I know my c. What is my a? I have to compare this one. A, okay, look. A x squared plus b x plus c. My a equal to positive 4. What is b? Look. Told you how you compare this, you know what I'm saying? B equal to negative 8 and C equal to 3. Okay, so I'm going to plug it in here. So look how I'm going to plug. You're going to be very, very careful here, okay? So x equal to negative is negative. Put your bracket whenever there's a letter here. B, what is my b? B equal to negative 8. Very careful. Write your bracket. Most of the time people forget bracket, and my b equal to negative 8 is going to come because look, you do it like this. It goes there inside. Plus or minus, and then go square root b. But b equal to negative 8 square 4 times a. What is a? A equal to 4. C, what is my c? C equal to 3. So now this line must start from here. From here, 2 times a. What is my a? A equals 4. So my x-intercept, my x-intercept means face negative 8 times negative 8, 64 minus this and this is going to be 16. 16 times 3, 48. But we have a root. So this minus this is going to be 12. 64 minus 16 times, okay, so now 64 minus 48, 64 minus 48, okay, 16 I think, yeah, 16, yeah, 16, so this stuff here is going to give us what, 16 here inside, so it's like square root of 16, look, square root of 16, and then here plus or minus, and this is negative 80, and this is equal to 8. So my x equal to, now this will be negative 80 plus or minus square root of 16 equal to 4 over 8. So now, if you look careful, I can have a two value of x because I have a plus or minus. So you have to do for the plus, and then you have to do for the minus. So for the plus, we will say my x first, it could be either negative 8 plus 4 equal to negative 4 over 8, negative half. Or negative 8 means this with this. It's going to give us negative 4, which is negative 4. Let's go slow. Some of the people didn't know how this comes. The first x equal to negative 80 plus 4 over 80. Or another x equal to. So now we're going to do the same process but for the negative now. So it's going to be this with this and then. So negative 80 minus 4 over 8 over 8. So my x equal, this is going to be negative 4 over 4 over 8 equal to negative a half, or you can say 0.5 negative. Now you come here, or our x equal to this and this is negative 12. So negative 12 over 8. By 4 you get 3, by 4 you get 2, but there is a negative here. You know what I'm saying? So negative, and then this is going to be equal to negative 1.5. So these are x-intercept. They are two, like 2 x-intercept. And when x-intercept, y equal to 0. When x-intercept, y equals to 0. So I believe you know how to use the formula. I need a space, so I'm going to raise here. Okay, so we have x-intercept, negative 0.5 and negative 1.5. Negative 0.5 and negative 1.5. Okay. Okay. So we have x-intercept, right? Okay, negative 0.5 and negative 1.5. Yeah, cool. Cool. Now let's go. So x-intercept, let me go right here. X-intercept means negative 0.5, but when x-intercept, look, y equals to 0. And another x-intercept, negative 1.5 and 0. We have already x-intercept. Now we want to go for y-intercept. Easy. So when y-intercept, x always equal to 0. Oh, means this is going to be 0, 0, so it's like C. C is y-intercept. So this may say when x equal to 0, y equal to this value 3. Because this is going to be 0 times 4, 0, 0, 0, 3, 3. So we have an x-intercept and y-intercept. X-intercept, intercept, and this is y-intercept. Okay, so now we got x-intercept and y-intercept. Now we want to go for turning point. Turning point is very, very easy. Okay? Turning point is very, very easy. There's just 2 or 3 formula you can use. Okay, the first one you can use the formula. Say turning point is where the graph turn. Turning point, or sometimes we call it stationary point. Stationary point equal to negative b over 2a. This is a formula used. So sometimes you forgot this formula. Let me show you now how you can remember, just in case sometimes you forgot, and how can you remind yourself. So you see the formula I gave to you first time, like negative b plus or minus b squared minus 4ac over 2a. So if you want to get turning point, if you have this formula, and let's say you forgot that one, so what you do, you take this. You see this one? This is what you need. This is give you x at turning points, negative b over 2a. You know what I'm saying? So turning points, the value of x at turning point, so this is what you take, okay? So this is what you need for you to get turning point. So this, you're going to say to get turning points means it must be x at turning point and also y at turning point. So start with the x at turning point. So to get x at negative b over 2a. So x at turning point, I'll say x at tp equal to negative b over 2a equal to negative, make sure you put your bracket, b, what is a b? B equal to negative 8. We know how to get them. Negative 8, so here I'm going to say negative 8 over 2 times a. What is my a? A equal to 4. So this is going to give us negative positive 8 over, this is going to be equal to 8 equal to 1. Oh, so our x at turning point equal to 1. Okay? So if you get this x at turning point, take this value and put it in here. You see this original question? It's going to get you y at turning point. So y at turning point now, because we got x already, so we want to get y at turning point equal, look, 4, and then take this x at turning point, put it in here in the position of x. It's 1, right? Square. Minus 8, 8. Okay, this x equal to 1 there. Always put your bracket. You know, I'm used to bracket. Bracket is going to save your life, baby. So I say plus 3, plus 3. So now this is going to be 1 square equal to 1 times 4 equals 4. Okay, this is going to be negative 8 plus 3. Okay, this and this 7, 7 equal to negative 1. Okay, so why a turning point equal to negative 1? So I would say turning point, or sometimes we can call stationary point. X a turning point equal to 1 and Y a turning point equal to negative 1. So you have all that you need. So now you can draw your graph. It's easy. Okay. Oh, I forgot. Axis of symmetry. Axis of symmetry. You see this X a turning point? This X a turning point, you call it axis of symmetry. It's the axis of symmetry. But man, what you mean? Why you call this axis of symmetry? How do you know? Or what that tells you this axis of symmetry? When somebody says symmetry, let me find a good example. Just a minute, sir. Just second. Oh, I can't see, man. What I'm going to use now? It's okay. Let me show you. Okay. Symmetry, for example, if I have a, let's say, something like this. Okay, symmetry is the line whereby when you split whatever you have, it's going to give you two equal parts. So I'm sure I can draw here. So this axis of symmetry. So we have only one because this is going to give you same half. But if I do like this, it's not axis of symmetry because it's going to be looking different. So this could be because if I split here, it's going to have the same thing. So now if I have this, let's say this is a graph of quadratic, and there's something like this. So I know this is going to be axis of symmetry. But where this is going to cut, this is going to cut a turning point where the graph turns for me to have a two equal parts. You know what I'm saying? It must be two equal parts. So that's why this value of x at turning point, which is this, what we call axis of symmetry, means this is the axis, which is going to be at x at turning points. Okay? So yeah, so axis of symmetry, we got it. So I mean this is the axis of symmetry. So now we can draw the graph for this case. Now let's draw a graph quick. I'm going to draw a very small graph here. So we know where the graph is going to turn. The graph is going to turn face. How is it going to concave? It's going to concave upward because this is greater than 0, 8. So the graph is going to go like that. And where is going to cut at y-intercept? Positive 3. Positive 3. Positive 3. Okay, cool. You don't make, I think I made a mistake here. But here we go. Okay, now we go. Felt like I made a mistake here, man. That's how I feel. You don't make sense just by looking. Okay. What is x-intercept? X-intercept equal to, we say, negative 0.5. So everything is going to be on the left here. No. Because if you look careful, okay, let me do this. I know. Negative 0.5 x. So let's, and then another negative 1.5. Let's say this negative 1. Let's say this negative 2. So this negative 1, this negative 2. So the first one is negative 0.5, means somewhere here. Negative 0.5 is like negative 0.5, and the other one, x-intercept is negative 1.5, means it's going to be somewhere here. Negative 1.5. Where is turning point? Turning point is negative 1, positive 1, negative 1 means x is positive 1. No, I made a mistake. There's no way it's going to be like that. So I might have made a mistake somewhere here. Let me look careful. Maybe how this must be a mistake. You know what I'm saying? Let me check again my x-intercept. Quick. I hope you don't mind. Because I believe I made a mistake. Just a minute, okay? So the formula say x negative b plus or minus b squared minus 4 ac over 2a. This with this x-intercept. So now let's correct it. X equal to negative b. I think so when I substitute I made some silly mistake. B squared minus 4ac over 2a. So x equal to negative. What is a b? B equal to negative 8 plus or minus negative a squared. It's going to be 64 minus 4 times a. What is a? A equal to 4 times c. What is a c? C equal to 3. And then 2 times a equal to 4. Equal to 4. Okay, cool. So our x equal to, okay, this positive 80 plus or minus, this is going to be for 80, which is going to be 16 square root over 8. And this is going to give us, oh, so this is supposed to be positive 8, not negative 8. That's how I made a mistake. This is a positive 8. So this is going to be 80 plus or minus, and this is going to be equal to 4 over 8. You see how I made a mistake? I also make mistake too. So that's how it was a problem. So now this is going to be x equal either 8 plus 4 equal to 12. So this is going to be 12 over 80. Or 8 minus 4 equal to 4 over 80. So now x equal to, this is going to be by 4 equal to 3, by 4 equal to 2. or a half. So equal to 0,5, and this is going to be equal to 1,5. So everything is positive, 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 positive. Oh, so this is supposed to be positive, 0,5 and 1,5. I made a mistake, I apologize. So for that case now, but everything else is correct. So now for that case, this is wrong here. So this graph is going to be 1,5 on the right hand side. You know what I'm saying? Okay, so now I know my turning points, everything. So now let's make some space here. So I know my turning points, so I can just write my turning points here, my TP equal to 1 and negative 1. Okay? So I don't need this, okay? But let's just draw here. I think the space will be enough. So the first one is 1.5. And okay, let's say this is 1. Say this is 2 and 1. Okay. I don't need this other crap. Let's write what we need. Okay. Positive 1, 0,5, 0,5. And the other one is 1.5. Let's say this is 1.5. You know what I'm saying? If you want to do that, say, oh man, how did you know that, man? So you could say, oh, for example, if this is 1, this 2, 0,5, let's say is here. And 1,5 could be here. So I can say this I don't need. And this I don't need. It's no part of what they asked me. So 0,5 and this is 1,5. 1,5, which is this one. Here. Now, what is our y-intercept? Y-intercept equal to 3. Y-intercept equal to 3 means y means 1, 2, 3. Let's say here. Okay, now turning points. What are the turning points? 1 and negative 1 means if this is 0,5, this is 1, and negative 1 means they're going to meet up here somewhere here. 1 and negative 1. So for that case now, I can draw my graph. So my graph is going to go, how is going to concave? It's going to concave upward because this a is greater than 0. So this graph is going to concave like this. It's a rough sketch. So you do this, and you do this. So this is the quadratic equation. So this is turning point, and this is vertex. Vertex is this line here. So vertex, line of vertex, x equal to 1. Okay, so vertex, x equal to 1 at the vertex. So vertex turning point to stationary point. So vertex x equal to 1, and how it's going to concave? It's going to concave upward. And y-intercept, and these are x-intercept. Thank you so much for your time and for all your patience. Now let's go for the question number 2, okay?